Hi there, welcome to yet another video. Today we will be looking at Python loops, and this promises to be a very comprehensive video where I would teach you, or you rather learn, how to do for loops, while loops, and to loop over lists, dictionaries, comprehension sets, tuples, and a lot of other stuff. So it's gonna be very um, educative, and so please stick to it. If you have any question, drop it in the comment. If you love the video, hit the like, subscribe, and catch you up in subsequent videos. Okay, so let's get it going. And so we started with the for loop. So when do you need the for loop? You use the for loop when you actually know the number of iterations that you need to like execute a certain block of code, for example. So for instance, you're doing something here, and maybe what you want to do is you actually want to maybe print this number, and maybe let's just say um, I am I am at index I. Okay, and so with the for loop we want to perform that operation how many times? 5 times. This is the range. And so if you want to do the same operation 5 times, instead of like copying the code and pasting it like 5 times, you could use a for loop. And then with this, you could use this particular index to like iterate over that particular source. So if I run this, we'll see what I mean. And so it printed the first one out of the range of 5, that it was 0. That was the value of I. And then it went it through the loop again, and then printed when the I changed to 1 until I becomes 5. And so that's a for loop. So it could be anything. It doesn't have to be a print. It could be anything. It could be a math. Maybe you want to do square, or you want to do square root of numbers. And so you could do something like maybe print, um, and here you could do a math, maybe mp. Actually, I did not import there, so let me use what is in the memory. And so I could do something like I raised to the power of 2, so I'm just squaring the I. And so I could just say something like the square is that value. And so it's basically squaring the value of I each time. So if you do that now, you could see that it printed this particular value, but also it computed the square of that particular value, and it was 0. Square of 0 is 0, and then square of 4 is 16. And so with the for loop, you use it to like when you want to like iterate over a certain process or a certain block of code, then you could use the for loop. So the syntax goes with a for, which is why it's called a for loop, and then you provide that instance that you want it to run. In this case, it's a single value out of this range, which would be a list of like 0 to 4, which have five elements basically. And then you use this will be the handle, because this will be the current number, and then you use that to like perform your task. So it could be like maybe you have so many images in the directory and you want to operate on each of these. So maybe you want to crop each of the images, then you want to do them one by one. And so this is how you grab them. You grab them in the list, and then you pick the first one. This could be a list, and then this could use to slice or anyhow you want to arrange it. I'll show you another smarter way of doing that, something like that. But yeah, you just grab this particular index and use that on top of whatever operation you want to do. So that's how you do for loop. Just start with the for, you provide the index, and then you give it a number of times you want to do that particular operation, and then you indent and then paste in your code and run it, and that will do the for loop for you. And so with the for loop, you could also like, this was like looping through numbers. You could also use it to like loop through lists. So in this case, I'm using strings, and these strings are in the list. I'm pretty sure you're already conversant with lists. If you are not yet conversant, please go back and watch some of my videos where I explain this in details. And so here I have a list of fruits. So I have apple, I have banana, I have cherry. and this all I call them fruits. Okay, so now this in the list. I could loop over this list and print the fruit, for example. And so in fruits, the three of them are present. But if I do a fruit, then it's going to this list and picking one at a time. So if I do a print, then you print this, and then to print this, and then to print that. So I'm gonna run that code, and then it printed all of them. So the first instance, it found this. I could move it around, and then wherever it's first, it will find that, and then it will print the next one. So you could also loop over lists, and those lists doesn't have to just be numbers. They could be strings, and so this is another way. So this is called looping through a list, and this is how it's performed. Great. I've already explained the range, which is if it's a very common tool or a very common function that you would be using if you are using a for loop. If you want to do a for loop, and so in a range, usually you have the smallest number, which is your start, and you will have your ending number, which is the biggest number, and then you have the interval, so how it should jump over. So in this case, we're saying that you go from 2 up to 10 with an increment of 2. So the numbers in this particular, if I print them, you should go from 2, you should go from say 2, 4, 6, so these are all even numbers below 10. Okay, so if I run this now, then I have 2, 4, this, and remember it's below whatever the last value you provided. But as I use range, you could use range to like generate like a list of numbers that you could use for the looping. So compared to like the first one where we're going from just, if we just provide a single number, it will generate by default from 0 to that particular number without including that particular number with an increment of default of 1. So that's default value. But if you want some specific intervals, then you could provide the intervals and the max and the mean, normal and minimum number. And so that's how you do that. There's another way of like combining your list with also knowing the instance in that particular loop, and that is through the enumerate. And so for example, you have names here, you have this Alice, you have Bob, you have Charlie, and these are all strings, and this is a list of names. Okay, you could like figure out which position is Alice in this particular list by using enumerate. So you could do syntax or for loop that looks like this now, compared to before that we're just having 4 in range. Now we're having 4, and then we'll have this index, which will be a number, and then we'll have a name, which will be one of the names here at an instance, and in a range of names. So this is like basically fetching all of this. And so what it's doing is that it fetches this first in the names, and then it gives it an index based on how many of them are there. So start with 0, 1, 2, and then it picks the first one and matches it with the first one. So you have, if I print the index here, the 0 will be Alice, which will be the name. So I'm here printing the name and the index so that we'll see what it's doing actually. And so you can see that 0, which is the first assigned to a name, Alice, and then the next one is assigned to that. So this is also very handy, most especially when you working with like strings, but you also need ability to assess that the position to which that string is in that particular list. So it could be like if you have list of directories, but you want that particular number to use it to name something that you're reading from that directory, maybe an image that you're reading from that directory. You want that number to give an instance of like the number for that image, then you could do something like this, and then you use this as a title on that particular image where you plot it, but you use the name to like load the data from that particular directory. So that's one practical application of using this enumerate. There's also what is called nested looping. And so with the nested looping is like you perform another loop within another loop. And so I'm showing this example with a for loop. And so you have a for I in 3. So this is going to go 3 in 3 positions. So you start from 0, 1, and 3. But you could also perform another function, another loop in here that is, it could be longer, it could be shorter, it doesn't matter. In this case, using a J, remember not to repeat this. If you repeat, it will overwrite. So you do the second one, and it's 2 times. And so what will happen is that it will try to loop the first one, and then enter that loop, and then execute this, and then come back and then start the next one. So if I run this, then this is how it looks like. It starts with the first I, and then goes and run the first j, stays within the first I because the j will request already 2 times, and so it runs the 2 j's and then comes out into the next I and runs the 2 j's again, and then goes to the last I and then runs the 2 j's again. So that's the next step, looping. So you enter this loop, did everything that was here by looping 2 times, and then went back to the other one and did 2 times. That's how you do the nested looping. Now let's go into another form of looping. In this case, it's called a while loop. So with the while loop, compared to like the for loop where you like know the number of times you want to loop over, the while you don't have to know the number of times you want to loop over that particular operation you are trying to perform, but you could know some conditional. So for example, say you want this particular operation to keep on going until certain condition is met, then you could use a while loop. So for example, like provided the temperature of your room is not above 50 say Fahrenheit, then the lights shouldn't turn on, for instance. And so that's a while loop because you have like some temperature, and it's going to have a thermometer that will measure the temperature. Provided that value is less than that value you're looking for, that operation will like keep on executing until you still like in active form. And so here's an example. So you can here we initiated a counter started with 0, and we check that provided this value that we initiated as 0 if less than 5, could be some threshold, then it should keep on printing the counter. And in this case we're incrementing it, so after printing for this first one, then we'll add a 1 to it, and then we'll go again and then add another 1, so the next time becomes 2, and then we'll add another 1, becomes 3, until once it's 5, this while loop should continue going on. Okay, so if you run this, then you could see that it will stop after it reaches 4. That's when the conditioner is like, that's the last place that you have a number less than 5, which is 4, and then it exit. If not, this could like run to eternity, okay, or until your computer crashes. Just kidding. Okay, so another way is like you could also use while looping to like decreminate, or sorry, reduce or decreminate like counters, like reduce counters basically. So if you start a counter from 10, in this case we increased, you could also reduce. That's what I'm going to show you. Starting at 10, and then you check that until the number is greater than 0, then you should keep printing the number, and you're minusing 2 each time you do the operation. And so that will go like from 10, 8 all the way to 2, and then it will exit after that. You could also have a nested while loop, so it could check the first condition. If that condition is met, then it will enter there and then try to like check the next condition. So just like I explained before, it's the same way. So it has 2 i's, so it has I1 for the first one. It enters and check that this condition is met, and once the condition was met, it came out and then went to the next index and then checked again. They continues like that until everything is happy. Great. You could also have like loop control statements, and so you have a for loop, and within that for loop you have some if statements, and then you could like break out if that particular condition is met. So in this case we want to loop from 0 to like 10, in this case 9, index as 9, and then we check that we're interested in getting a 5 out of this loop that we're doing. So whenever this number equals is 5, matches 5, then we should stop looping. And so you could do that by using a break, which is another keyword. Okay, and then that is to print the value. So if we run that, then it will keep on going until once it reaches 5, then it will break out of the loop. So that's how you break out of the loop. That's what I want to show you there. The next is to continue. And so for example, you want to loop over a certain range, but you want it to continue if it found a particular number, in this case 2. Then you could just say if none is equal to 2, then continue. and then you just kind of like skips the 2 and then still continue through that, looping through the next ones. And so it skips the 2 and then goes to 3 and then goes to 4. There's also a pass. A pass is like a placeholder for like future code. So if you're like trying to like write something and maybe you don't want, your code is not yet ready, but you don't want your code to crash because it's required for it to be there, then you could use a pass. And so pass will like kind of like be a placeholder just to make sure that this syntax works. So suppose if I remove this here, it will crash because there is nothing. You can't just have an empty for loop. There must be something. Pass is what always there. And so I run it without getting an error. But if I comment that, if I run it, I'll get an error because it's expecting some code to be present. Okay. There's also what is called else within loops. Again, we use the if, but what if you don't want just to check one condition, then you could use an else. So in this case, we just find range of 3 and then we'll grab each number, we'll print it, and then once it's done, that's the else, then it should like say it's completed. I mean, you could add this at the bottom, but that will like print it each time. So this is the only way that you get it to print when it's done. It's a good way of notifying you that the job is completed. So you could use an else statement there. And then there's also what is called iterating with the zip and the map. So this one is just like you have a list and have a list. You could like relate element and element and do some operations. So in this case, we have names, and the names are 3 people, and then have their ages. Each one corresponds to each of the individual people. So with the zip, you are able to like link this particular to this person and this one to this person and this one to this person unsuccessfully. And once you have the zip, then whatever you provide here, in this case a list and a list, then the name will correspond to this one. You to grab the first one, the age, you grab the first one that matches that particular one. Remember, the index is like the number of elements and needs to be the same for it to work. And then here we just print the name and the year without matching, without mismatching stuffs. So if I run that, then it tells us that this first person is this old and the last person is this old, and that's what you have there. And so that was like we're using the zip, but you also do map. And map is very handy when you especially want to like use like the anonymous and function called lambda that I introduced the last time. And so you have, for example, numbers going to 4, then you could take the squares of that particular number by just doing the operation here and then getting the keyword or the key here and then passing in those numbers, how many of them you want to go through, which is those total input. And so that's another way of looping through numbers. So in this case, we like perform operation on each of this one without using like a for loop, but this lambda function was able to like do the same thing for us. You could also like go through like dictionaries using the same thing. And so here you have a list. It is like a list comprehension because it's actually a list. And there is a for loop where everything is on a straight line compared to the way we had it before, that it was being indicted. You have a square of x, and then you provide for each instance of x, the value should go from 0 to 4. And then you print those, then that will do the operation for you and give you the squares of numbers between 0 to 4. There's also similarly what is called a dictionary comprehension, which is just similar to what I've explained before, but in this case you have a dictionary, and the differences are in this case you're going to have these curly brackets rather than a square bracket, which is for list, and this is like for dictionary. And again you're going to have the key, and then you're going to have the value, and then you just perform your loop operation. If you run it, then you have those. So this could be an alphabet, and this could be a number. Doesn't matter in this case. This is just an example, but of course you have these two linked together. This is how the dictionary looks like. There's also what is called advanced looping technique. You could use things like the itertools or the itertools. And so for example, you have like an infinite loop that will stop maybe after a break, infinite, you don't know how much you should go. Then you could just use this itertools. So you could do something like for norms in itertools count one, that's the increment. Then you should print the number, but if it reaches 5, then you should stop. So it will just like the way we did a counter before, but in this case automatically increases by this certain interval provided. So if I run, then it goes from 1 until once it reaches 5, then it breaks and then stops. If we change that to 15, it will go until once it reaches 15, then it will stop. And so that's itertools. It's good to like know some of these so they don't have to like do a lot of like brutal coding that of stuff that are already available within Python. So that's the essence of this last portion of this code. At this point, you should already be familiar with looping. Let me know if you have any questions, just drop it in the comment section. And if you have already learned something from this video, remember to hit the like button, share the video, but also subscribe if you haven't subscribed yet. There's also a way of like generating expressions, and so this is an example. You have a chain and you have this sort of stuff that looks like a tuple comprehension, because it's a tuple, and then you have this square for x in these particular values, and then this will have like some value, and then you could print those particular output and then go to the next one and just loop and skip the next and print all of them, and that's what you have. So you got the first one and then compute it for the next, then compute it for the next. So just form of like a generator. You could also use like this particular loops or these generator functions in like standard functions. You could define a function, apply this within it. Here's an example. You just define, we process certain data. Most people want to like do batch processing. This is like a good technique to do. So you have a function and then within it you provide other indices upon which you want to loop. And so here we do for I going up to this big number, and then we tell it to yield this particular value. So just generate a number one by one. That's just basically doing. And you could also call this particular function, grab the value and check if it's less than something, and then you could stop. Yep. And so at this point you have, if I learn everything that you need to know about loop. There's nothing about loop there, it's not covered in this particular video, but here are like the ending stuff that you should just finally take note of before exiting. And these are stuff that I usually try to do at the end of my videos. They are like best practices, and sometimes I will just comment on the common mistakes so that you just avoid them. And so for example, you have avoiding off by one error, which I've already commented on. So suppose you want your number to go to exactly 10, then remember Python starts from 0. And so what you want to do, if you want to go up to 10, you have to do a 10 plus 1. That way it will print up to 10. But if you just leave it at 10, it will print to 9. So remember there is an off by 1 issue in Python. So now we have it up to 10, but if we leave it at just like that, then it will stop at 9. So be careful while you're looping. There is also like a way of like optimizing your loops, especially when you're doing like batch processing. Try to use like list comprehension or dictionary comprehension or tuple comprehension, rather than doing this sort of like coding that is not very Pythonic. So this is like a loop, and then sometimes you have an if in it, then it makes stuff really slow. So you want to use this more, something like list comprehension. It's more optimized for like trading and other stuff, so it produces faster results. And then the last one is like handling nested loop. Just try to avoid this kind of style of coding, except if it's like if you really need it. With that, that's the end. We've covered for loops, we've covered while loops, we've done like loops, control systems, list comprehensions, and optimizations. And with practice, you become expert. Peace. See you in my next video. Bye.